Okay, let's take a look at this PX30 soft flexible polyurethane rubber then. As I say, this is not a chemical that I have much experience using, so I've done the usual thing when you pick up a chemical that you're not sure about. Check out the manufacturer's website, look at the safety data sheets and the technical data sheets, make sure that you are following all of their guidelines. And the description of this product says that it's suitable for taking soft castings for use on handles, grips, that kind of thing, but also for making molds for concrete applications, which I think is probably why we've got it. I think Luke bought this to have a look into some concrete casting a while ago, so he may have more experience using this than I do, but this is the first time that I've tried it, so I'm going to do a few experiments. So having checked out the safety data sheets, this is something that you don't want to get in your eyes, this is something that you don't want to swallow, this is something that you don't want to inhale too deeply nearby. So following those precautions, they're fairly standard for chemicals like this. Make sure that you're working in an area that's got fairly decent ventilation. Make sure you're wearing protective equipment, and make sure that you do not touch or rub your face until you've finished your application and you've cleaned everything up. So we're going to follow normal best practice procedures for setting up a mixing area for chemical substances. So I'm going to put a sheet down over my work area to protect that from spillages, and so that we can quickly and easily and safely clean it up afterwards. I'm also going to wear an apron, so here's a second polyurethane apron. I'm going to put that on to protect my clothes. A lot of these chemicals are not that easy to remove from clothing if you do get them on you, so make sure that you're protecting your clothing. There we go. I'm going to wear a pair of vinyl gloves. Now, there is nothing in the technical or safety data sheets that suggests that this chemical has any cure inhibitions, so it should go off whatever we put it up against, so there shouldn't be any problem. But you might remember I said in the silicone video that some chemicals are sensitive to latex, some chemicals are sensitive to vinyl. So there are some substances that you mix that you definitely want to be wearing vinyl gloves rather than latex gloves. And if you're allergic to latex, or you have any idea that you might be allergic to latex, steer well away from the latex gloves. Vinyl gloves are always a much safer option. Okay, I've got measuring scales. This product says to mix it 1:1 by weight. There you go, you can see that down the bottom there, 1:1 by weight. So I'm going to measure by weight. Always worth measuring by weight if you can. Even the things that say that you can mix them by volume, you usually get a much more accurate mix ratio. If you're measuring them by weight, it's much easier to judge by what the dial on the scale says than it is by eye. I am going to take two pots here, and one of these pots I'm going to label A, and one of these pots I'm going to label B. I'm then going to take a third pot and I'm going to label this mix. Okay, now if you're only mixing one batch, you can decide whether you want to do this or not, but if you're doing multiple batches, particularly when there's not that much of a difference in colour between the two chemicals, you want to really make sure that you're not contaminating by putting parts in the wrong pot. So it's good practice to have a part A pot, a part B pot, and a mix. Also, good practice when you pick up a chemical that has been sat on the shelf for a while that you haven't used recently, give it a really good shake, a really good stir, a really good mix. Sometimes active chemicals sink to the bottom, and you'll find that you get a very tacky mix, or it doesn't go off properly if you haven't shaken these up. it will usually say on at least one of the containers, the one that's got the active catalyst in it, it will usually remind you to shake it up. But just good principles to do that in any case. Make sure that you've got a few coffee stirrer mixing sticks handy. You may need to change them up, and you don't want to be digging around in cabinets while you've got stuff curing on the side. So take note of how long it says that this is going to take to cure. It should say somewhere on the packaging. If it doesn't, have a look on the technical data sheet, just to make sure that you're going to have enough time to pour that in between mixes. You want to pour as slowly as possible generally to avoid introducing air into the mix, but you need to know how much time you're going to have to do the pour. And then make sure that you've got your moulds to hand, or the thing that you want to make a mould of to hand, so that you're not trying to set stuff up after you've got a mix. Once you've mixed the two components together, you want to be getting them on as quickly as possible. So I have got a silicone mould, an aluminium tin, and a HIPS high impact polystyrene vacuum formed tray there. So I'm going to try and pour my mixture onto those three, wait for it to cure, and then we'll see what we get as tests from those. So here's my A pot, popping it on the scales, turning the scales on, find part A. Okay, this is part A, and this is 1:1 by weight, so this should be fairly easy. Just check my scales. Okay, so grams. Okay, so this should be fairly easy to mix. As with all chemicals, you want to get this as accurate as possible. Sometimes you're okay with a 1 to 2 gram variance, but because I'm only mixing a small amount of this, I do want it to be as accurate as possible. So I'm going to go for 30 grams of each. Let's go for 35 grams of each. Okay, that's 35 grams of part A. Part B, check the scales have zeroed again. They have. And be aware that some of these chemicals, one part will come out at a much higher speed than the other will. So just be prepared to moderate your pouring accordingly. This is why it's good to do them in separate containers, because then you can add or remove material from them if it gets too... Ooh, there you go. See, that's coming out quite fast now. You can add and remove material if you pour too much in. There we go. Okay, 35 grams of part B. Let's get the scales out of the way. Right, here's my mix beaker. I'm going to try and pour these simultaneously into the mix beaker. And then part B is actually much thinner than part A in this mix, so I'm going to use my scraper just to make sure that I've got all of the remaining parts of part A in there. Otherwise I'll be putting more of part B than of part A in, and that's not a good idea. So scrape that out, there we go, and give it a really thorough mix. You want to make sure that you scrape the sides, you scrape the bottom. This is quite a thin liquid, so it's not difficult to mix. Some of the silicons and some of the other rubbers are much denser, and it's much harder to give that stir through. But this is quite easy to mix. Okay, and then I'm going to pour a bit into the bottom of my aluminium tin there. I'm going to pour a bit into my hips tray. And I'm going to pour a bit into my silicone mould. Just to see how that comes out. Let's pop a bit more in there, a bit more in there, and we'll leave a little bit in the bottom of the beaker so that we can see how it comes out of a waxed paper beaker as well. Okay, then I'm going to put all of this to one side, wait for it to dry, and then we'll come back and see what we've got. Right, it's been 24 hours, which is the listed cure time on the Easy Composites website. So let's see what we've got. Start off with our clear tray here. It's still a little surface tacky, so I'm going to put some gloves on just in case. It's never worth putting raw chemicals on your fingertips if you can help it. Okay. Now part of that tackiness might be that it was quite cold up here overnight. Part of that tackiness might be that it hasn't been quite 24 hours. We're looking at about 23 hours here, so it shouldn't make a lot of difference. Partly that it needs a slight post-cure. But let's see what we've got here, if I can get it out. Okay, there we go, it's starting to go edge here. Okay, so here's our square of rubbery material. Let's see. Ooh, that's very stretchy. It feels harder than the tin silicone. The tin silicone here is a Shore A30, and yeah, this is a thicker bit, but it doesn't stretch quite as far as this. This is very stretchy. Still a little bit on the sticky side. This is very stretchy. Look at that. But a bit more rigid. Okay, good. That's a first test. Not too many air bubbles in there. So if you're going to pigment this and use it as a final product, you might want to degas it before you pour it in a vacuum chamber and pull all the air out, and then you won't get this this speckling, this air bubbles in the surface, which I don't know if you can see there. For a mould, this is absolutely fine because there's nothing impacting the surface. That's all clean and smooth on both sides, so not necessarily so important to degas for moulding, but for casting a final product you definitely want to degas that. Okay, there's that one. Let's see if I can get the one out of the tin here. It's going to be a bit trickier because it has an overhanging side. But it's peeling away quite well with the aid of a coffee stir around the corner. Okay, there we go. So this is a thicker chunk, still not quite as thick as the silicone, but a thicker chunk. And yes, it's still got more stretch to it. So if you were doing a very hard object like it suggests for concrete casting, or maybe even for plaster, although you'd want to use a very tough plaster and make sure it was thoroughly set before you tried to get it out of here, but if you had a very hard substance in there and you wanted to be able to flex this to avoid any tearing in the mould, this would probably be a good material to use. Yeah, and even freshly cured, you can see once I've given it a really good pull, it's coming back to its original form. There's no distortion there in that disc, so that's good. Now let's try and get it out of the silicone mould. Oh, very, very easy. That just pops out. There we go. And the definition there is quite, you won't be able to see probably, but the definition on there is quite good. It's picked up the little detailing on there, so actually its casting properties pretty good as well. So this is from Easy Composites, as I've said, Zencast PX30 polyurethane rubber. It's about the same price as the Tincure silicone. It's £1 more expensive. Not as environmentally friendly. This is all oil-based, petroleum-based chemicals. And would I use it? I'm so used to using silicone, I'd probably use silicone for most things. But if I was doing a large concrete piece or a large, really hard resin piece, and I wanted to get away without a support structure around the outside of it, and it had some intricacies that would need a flexible material, then yeah, I would consider using this. I think probably more useful as a pigmented casting material than as a mold making material, but it's a handy thing to know is available. So there, that's polyurethane rubber. We're going to have a look in the next video at some of the resins that we would use to cast into these molds. I shall see you in that one.